Okay, hello everyone. My name is Marc from Viktor Goes Green. We started research to gasification more than 10 years ago, and now we are ready to go to the market with some installations. We built installations for the production of biochar and take the initiative to set up our own productions also. This can range from small installations of 50 kilograms per batch installation to industrial projects of several tons per hour. Today, I would like to introduce you to two projects related to biochar production. In our workshop in Ghent, Belgium, we developed a simple but very efficient device to produce charcoal or high-quality biochar. The device has been developed for the African market. During our visit to Benin in Africa, we saw the traditional production methods for the production of charcoal, and then we started tinkering with the design to produce the same amount of charcoal with less wood and fewer greenhouse gas emissions. When the demand came from biochar to use it in the pineapple cultivation from the Benin Agriculture Development Agency, we decided to start building the installations. With the support of the Belgian government, we have succeeded in building the first 20 installations for Benin. These 20 installations are a gift from the Belgian government to Benin and are being set up at various locations as a demo project. Some of them as biochar production, some of them as a charcoal production. The biochar will be used in the pineapple cultivation. The design of the reactor is a simple inverted barrel with a chimney through the middle. The barrel is open at the bottom, and you turn the reactor in a horizontal position to fill it. The combustion chamber is at the bottom. The fire to heat the reactor is only in the combustion chamber. The heat from the fireplace through the chimney in the middle and heats the reactor. In the reactor, you get the circulation of the produced gases, so the temperature is almost the same on every place in the reactor. The gases can only leave the reactor by passing the combustion chamber and inflame. This fire drives the temperature of the reactor to more than 400 degrees. Once gas production stops and the fire goes out, the charcoal or biochar is ready and of a very good quality. Some technical information. The capacity is 1.4 cubic meters. There are no electronics on the installation, no controls. It's an autonomous running process. So it's very easy to use it. And as I said before, developed for the African market. Compared to traditional methods, our installation only uses half of 1/3 of the wood for the same amount of the charcoal production. The production time and working conditions are much better, and in traditional ways, you spend more than a week to have one batch of a charcoal production. With our installation, it is normally one production each day. If you cool it down with water, you can do 2 or 3 productions in one day. On the left, you see the photo of a traditional method that is used almost everywhere in Africa. The process takes several days to sometimes 2 weeks. The gases leave the covered pile without burning. These contain high concentrations of greenhouse gases. I also included the instructions for use. It's a very simple installation to use. In the horizontal position, you fill the reactor. In this photos, you can also see the chimney in the middle, the closing covers to keep the wood in place in a vertical position, and the combustion chamber below. In the vertical position, the combustion chamber is closed with the reactor. The fire is only started in the combustion chamber. Once the reactor is above 200 degrees, the gases in the wood leaves the reactor bypassing the combustion chamber. This causes the gases to ignite. From now on, it is an autonomous process. The burning gases further increase the temperature of the reactor to 400 degrees. When the gases have burned out, the reaction is complete and you have to wait for the cooling. The result is a high-quality biochar with a carbon content higher than 90%. Of course, it depends on the biomass that you put in the reactor. So what is next of this project? We are now developing a system so that local producers of charcoal and biochar can use the installation for free. An installation easily costs between 13 and 60,000 euros, depending on the transport cost. It's still cheaper for local producers to use the traditional method. We want to set up a concept with local parties that can demonstrate how much less greenhouse gases are released into the atmosphere and how much extra CO2 is stored. It can be used for both biochar production and charcoal production. Local parties can be NGOs or agencies from ministries. My contacts for this project too. And the second project that I would like to present is our bamboo char project. Our bamboo project is located in Benin, where we want to turn our own bamboo production into bamboo char. Bamboo char is, of course, biochar made from bamboo. We have planted our own bamboo forest in Benin. Why did we plant bamboo? When you talk about biomass production, bamboo is a great crop to have a lot of biomass almost every year. The planting started in 2014. We planted parts in 2014, 15, 16, and 17. About 350, 400 hectares have been planted. There is room for much more. The first planting are now maturing and can be harvested. The big advantage of bamboo is that it can be harvested every 3 to 4 years once the plants are adult. And we use no irrigation and no chemicals. We only mow the undergrowing vegetation once a year. This is the schematic representation of what we want to do with the bamboo. We want to sell the better stems directly, of course. You can use it for construction wood, for example, or for other constructions. The rest is chipped and goes into the installation as a feedstock. This installation is a continuous installation with a gasifier and a cogeneration. The installation uses 1 ton of dried bamboo each hour. This produces 700 kilowatts of electricity, 250 kilograms of bamboo char, and the rest is heat. For the heat, we are looking to use it for local drying of fruit, nuts, and rice. We are in the middle of the production of cashew nuts, and they need a lot of heat, and almost no cashew nuts were transformed in Benin. Almost all those cashew nuts go to Vietnam to transform over there. So it is better that they can do it locally with the heat of our installation. Here is a better view of our gasifier. The red tube at the bottom is the place where the bamboo char comes out of the installation. On the right, you see a complete setup from storage bunker to cogeneration. The total investment of this setup is 2 till 2.5 million euros. but we can make it as a really a good project um, because there is a big demand of industrial biochar. The electricity and the heat will be valorized locally, and we are currently negotiate with major industrial consumers for the sale of the biochar. And there are still my contacts and two photos of the partners of the Benin project. Thank you.
Thank you very much, Marc. So you got some questions in the chat, but if anyone else wants to ask a question, please raise your hand or just write into the chat box. So I had one or two questions. First, for your first project, the low cost or easy reactor. So I was wondering, is that made of stainless steel or what? How do you come to 16,000 euros? Um, is it produced in Belgium or?
Yes, it is produced in Belgium in our workshop in Ghent. Yeah.
Ah, okay. Yeah,
Yeah.
that makes sense then. And is that something that a local partner could reproduce or is?
Yeah, yeah. We
Okay.
didn't take a patent on it. Everyone who want to copy it, he can copy it. I don't have a problem with that. If there are a lot of installations, it must be a good installation to copy by too. But what we will do is something different. We would like to give it for free on the local producers with the support of some NGOs and agencies, and we can make profit with the CO2 certificates.
Mhm. Okay, makes sense. And the my other question was, do you know the weight of the reactor once it's like the total weight of it?
The reactor is almost 1 ton.
1 ton. Okay.
Yeah.
So you got two questions in the chat. First one from I guess a student email address. Is it possible to get the blueprints of those reactors, which you already partially answered?
We can share something, yeah. No, no problem.
And the other one is from John Hoffmeyer, who was asking, please explain again how your equipment is self-extinguishing. When the fire in the firebox at the bottom goes out, what
Yeah,
stops the char from burning with the same oxygen that fed the firebox?
yeah. As I said, the installation is an inverted barrel, so there can no oxygen go into the reactor. It's only in the combustion chamber that oxygen can come in. It will not burn. We have used it for several times, and never we saw burn inside in the reactor.
And did you try other feedstocks than wood?
We tried some other feedstocks, but wood will be work the best. Yeah. We tried also briquetted sawdust, for example, but also briquetted cashew nut shells. But that's not so easy to do. It worked the best way is with particles of food. Yeah.
Yeah. So follow-up questions, I think. Um, from Paul Anderson, what are the size variations, I guess, of the reactor? Paul, please.
The first of the second project.
Yeah, that's also a good question. I think the first one, because this follow-up question is, what's the price euros in 13 to 16,000 or 60,000?
No, 16,000. Yeah.
And I guess he meant the size of the first project reactor.
Yeah, the reactor is 2 meters and a half high.
And did you try to up or downscale it?
Yes, we have once made some bigger installation till 4 meters, but then it is too big to handle it by hand.
Okay, yeah, that makes sense. Um, so Marshall Memel was asking, is this a form of gasification or pyrolysis or a combination?
It's pyrolysis. Yeah.
Okay. And then another question from Dirk was, what's about fine dust and smoke when you have a lot of units at one site? So do you see a lot of emissions?
I can say there is, of course, fine dust and some smoke also during the reaction. But when you look at the traditional methods, there is a lot more. So we are doing better on greenhouse gases, but it's almost the same with fine dust. But we are doing better, and that's what efforts are installation.
And then a last question from Paul, I guess. So it's a retort, the reactor.
I don't know exactly what a retort reactor is. What is a retort reactor?
The typical drum reactors have, for example,
Yeah, it's a drum reactor. Yeah, yeah, yeah.
so I would also say, yeah, yeah, okay. Another question from Trevor was now, is the firebox a rocket design?
No.
Okay, okay, that's a clear answer. Um, and I had just the last question for your second project.
Yeah,
So, I already do you have the equipment already, or is it in planning?
it is in planning, but we are working together with German partners for the gasifier. And of this gasifier are two or three installations running for more than 3 years, and they are running very, very, very good. So it is
And
approved.
can you already estimate what's the price of the biochar of the bamboo char that you will try to achieve?
The price of the biochar?
Yeah.
Yeah. When the quality is good, when we produce a high quality, why I would like to explain a little bit. We are discussing with a lot of industrial consumers or interested industries to buy our biochar, and there is a big difference in the quality that I need. For
Yes.
example, the chemical industry, they will a biochar what is very clean with a high carbon content. But other industries, they don't need the highest quality. So there is a big difference in the price of a high quality and a lower quality of biochar. But I can say that the lower quality of biochar also we demand the price for it, and that's the basic to sell our biochar of more than 600 euros a ton, and of the high quality, and that's a quality with more than 90% of carbon content. We are talking about 900 euros a ton.
Okay. From Benin or at the port in Europe?
Um, uh, no, at a port in Europe. Yeah.
Okay.
Yeah, we have also a third project, and maybe I can say something about it. It's too quick to give already some big information, but in our area, we have the permit to construct a very big installation. And we can transform in this installation more than 400 tons of biomass into biochar, 400,000 tons each year. And it is especially with this installation that we are talking with big consumers or industries to buy our biochar. And the prices are based on this installation. But
Okay.
also what we will do in Africa, for example, we will sell it in the same market.
Okay. So the last three questions now, they all go back to the first project. So Paul is very interested, apparently. So what is the fuel for starting until the combustible gases are made?
Yeah. It depends on how much water is inside your biochar, your biomass. When it is really dry, you just need 10% of the wood that is inside in the reactor to start up the installation. When it is more humid, you need more, of course, because you have to dry it in the installation. But it is better to dry it beside the installation and bring it dry into the installation, and then you just need 10% of the wood that is inside the installation.
And Santiago was asking, is the reactor used to process boat wood or balsa wood that is not very dense and light? So do you have any
Uh,
specification on that?
I know balsa wood. I think it will work. I think it will work. I don't see a problem, but we didn't test it.
Okay.
But we have done several tests with European wood, hardwood and softwood, also big parts and small parts of bamboo, for example. It works always the same a little bit. So there is no big difference between woods. Only if the humidity is too high, then it will take time before it is really running.
Yeah.
But best is to dry it, and in Africa it is no problem to dry it in the open air before you put it into the reactor.
Okay. And
What
then
we can do also to make the price a little bit cheaper is that we are not welling the installation completely in Belgium, but that we send it in parts to some consumer or someone who is interested to buy some installations. Then more installations can go in one container, and we don't have a lot of work at the installation to prepare the installation. Then everyone can well it on location where they will set it. Yeah.
okay. So if anyone is interested, I think there's still Marc's email address on the
Yeah.
screen, so that's good.
Yeah.
And the last question now is again from Paul. I will change it a bit. Do you measure the maximum temperature you reach during the process? Because
Yeah.
you said it's above 400, but where
Yes.
where do you get to?
When the wood is very dry and produce a lot of gas, it will go till 450, maybe a little bit more, but not more than that.
Okay. Okay, great. Thank you, Marc. So we are
Okay.
basically on time.
Okay. Thank you
Um,
very much for the possibility.